Hello. Today I'll talk about the derivation of trigonometric identities, specifically the Pythagorean identities. That's sine theta squared plus cosine theta squared equals 1, tangent theta squared plus 1 equals secant theta squared, and 1 plus cotangent theta squared equals cosecant theta squared. At this point, you must already be familiar with the Pythagorean theorem, which states that the sum of squares uh, of the legs of a right triangle is equal to the square of the hypotenuse. In books, we normally see them represented by the equation c squared equals a squared plus b squared, wherein a and b are the legs of the right triangle and c is the hypotenuse of the right triangle. And this is the basis of these three Pythagorean identities. Okay, let's start with this one. This, as I've said, is based on c squared equals a squared plus b squared. Let me show you a unit circle here. A unit circle is a circle with radius 1 unit. Okay, so from its center to the edge of that circle is 1 unit. So this length here is the radius, and this is equal to 1. And any angle formed by a right triangle here can be called theta. Okay, we just call it theta. And we know that sine theta is equal to the ratio of the opposite side to its hypotenuse, which is 1. So sine theta is equal to y over 1. Okay, so we can say that y is equal to sine theta. And of course, one of its, as we said a while ago, a here and b are the legs of the right triangle. So a could be x and b could be y, or you can interchangeably, use a and b, x and y. And of course, c is the hypotenuse. In this case, it's 1. Okay? Now, cosine theta, we know that cosine theta is the ratio of the side adjacent to the angle theta to its hypotenuse. So in this case, this is x over 1. So we can say that x is equal to cosine theta. Okay? So that's how we derive this. In this case, the hypotenuse is 1. 1 squared is 1. A is y, or yeah, let's just say a is y. So this is y squared, and plus the other side of the right triangle is x squared. Okay? And we know that y is equal to sine. So y squared is sine theta squared. So 1 squared is 1. Y squared is sine theta squared plus x is cosine theta. So x squared is cosine theta squared. So that's how we derive the Pythagorean identity in trigonometric identities. Sine squared theta plus cosine squared theta equals 1. Okay, now how do we derive this? Tangent theta squared plus 1 equals secant theta squared. Before we proceed to the derivation of these two other versions of Pythagorean identities, let's also review the other trigonometric identities, and these are the reciprocal identities and the ratio identities. Now, it's easy to remember because, I remember my teacher told me, okay, when I was in, I think, third year high school. I don't remember anymore. That was a long time ago. just list down all the trigonometric functions. So we have sine theta, cosine theta, tangent theta, cotangent theta, secant theta, and cosecant theta. The reciprocals are sine and cosecant, cosine and secant, tangent and cotangent. Those are reciprocal. So let's list down all um, the reciprocal identities. So sine theta is equal to 1 over cosecant theta. That means cosecant theta is equal to 1 over sine theta. Next, cosine. Its reciprocal is secant. So cosine theta is equal to 1 over secant theta. That means secant theta is equal to 1 over cosine theta. Tangent theta is equal to, its reciprocal is cotangent, so it's 1 over cotangent theta, which means cotangent theta is equal to 1 over tangent theta. Very easy to remember. Okay, if you forgot, just recall this. All the functions, list them down, and just match the extremes. Okay, and work your way in to cotangent and tangent. Okay, so those are the reciprocal identities. Another important identity that we have to understand before deriving the other two Pythagorean identities is the ratio identities. Okay, so from the unit circle, we know that tangent of theta is the ratio of the opposite side to the adjacent side. So that's y over x. In this case, tangent theta is equal to, y is sine theta, right? So sine theta divided by cosine theta, which means cotangent theta, since cotangent is the reciprocal of tangent theta, cotangent theta is equal to cosine theta divided by sine theta. Okay? Now we all know we now all know this identities. We can now derive this. Okay? We derive this from, well, let's start with this sine squared theta. Okay? Let me just bring you to another page here, maybe. Sine squared, or sine theta squared, plus cosine theta squared equals 1. Okay, so sine, let's just copy that. The reciprocal of cosine theta squared is cosecant, right? Secant theta. So that means cosine squared theta, or cosine theta squared is secant theta squared. Okay, based on this cosine 1 over secant, cosine squared 1 over secant squared. Okay, is equal to 1. Least common denominator of these two terms is secant squared theta. Secant squared theta divided by 1 is secant squared theta times sine squared theta. That's what we write here. Secant squared theta sine squared theta plus 1 equals 1. Cross multiply. We just copy the numerator here. That's what's left on the left side. Secant squared sine squared plus 1 equals secant squared theta. What else? Sine. Oh, how do we get back there? Okay, so secant squared, secant is of course the reciprocal of what? This is 1 over, okay. How do I get back to my drawing pen? Here, okay. Secant. This is, secant is 1 over cosine squared theta. Okay, is that right? Secant squared. Secant, 1 over cosine. If it's squared, 1 over cosine squared. Times, oh, this is squared. Sorry, my mistake. Sine squared, sine theta squared plus 1 equals secant squared theta. And we know that sine over cosine is tangent based on the ratio identity. Sine over cosine is tangent. So sine squared over cosine squared is tangent theta squared plus 1 equals secant squared theta. And this is the other version of Pythagorean theorem, which is this one. Tangent squared theta plus 1 equals secant squared theta. Now we're down to only one left. 1 plus cotangent theta plus cosecant squared theta. Why don't you try? You can pause this video. You do the same process, just like what I did here, okay, based on sine squared theta plus cosine squared theta equals 1. Okay, so I hope you were able to, derive that equation. So in this case, again, based on sine theta squared plus cosine theta squared equals 1. Okay, this time we're going to get the reciprocal of sine squared theta, and that is 1 over cosecant squared theta plus cosine squared theta equals 1. Again, least common denominator is cosecant theta squared. We have here 1, and we multiply this by this, so we have cosine squared cosine theta squared times, okay, let me just write clearly for you. So we have cosine theta squared times cosecant theta squared equals 1. Cross multiply, we bring this here. So what's left here is 1 plus cosine theta squared times cosecant theta squared equals cosecant theta squared. And cosecant squared is of course 1 over sine, right? 1 plus cosine theta squared times 1 over sine theta squared equals cosecant theta squared. And we know that the ratio of cosine to sine is cotangent, and they are squared, so we say that 1 plus cotangent theta squared is equal to cosecant theta squared. And this is what we have, exactly like what we have here. 1 plus cotangent theta squared equals cosecant theta squared. So that's how we derive the Pythagorean identities.